welcome to part 12 of Project E55 ASL, and this part is going to be about making the multi-link suspension for this car, which is going to be the rear suspension for this car. For making this suspension, I'm going to be sticking with the same axles and spindles from the E55, but all the control arms and mainly the geometry of the suspension is going to be custom for this car. So for making the suspension, I'm just going to start off by first designing everything, making sure the geometry is right in the design, then actually fabricating the control arms and attachment points and putting everything together. And then lastly, when the suspension is put together, I'm going to be checking for bumps here, hoping that there's no bumps here, but if there is bumps here, then I'm going to have to make further changes to it and obviously eliminate that bumps here. But yeah, let's see how everything goes. Starting off with a bit of background behind the project for those of you that are just joining in. So this is a car that is roughly based on my Mercedes E55. I used to have an E55 that I used to race, and one day I was at the track and unfortunately blew the engine on that car. Now while I was fixing the engine and putting everything back together, I realized it's a pretty good time to actually use all these components in a proper, much more track-focused car rather than just bolting them back in a heavy E55. And that's really where this project came along. So what this project is most of the components taken from the E55, bolted into a lightweight tube steel chassis, paired with a suspension that is going to be much more appropriate for track use than the suspension in the E55. But just a few specifications of the car. The whole car, when it's complete, it's going to weigh somewhere around 900 kilograms. The width of the car is 2000 millimeters. That's the exact same you will find on most race cars like Formula 1 cars, Le Mans prototypes. The wheelbase of the car is 2930 millimeters, which is also really close to what you'll find on race cars. So pretty much the same dimensions, the same weight as a race car, the same horsepower as a race car, hopefully, once everything would be tuned and running. And so yeah, it definitely should be a really fast car, and it also should have a lot of downforce once I do get to the downforce part of the project, which is going to happen right after I'm done with all the structure and I get everything working. But anyways, the job at hand for this part is actually making the rear suspension for the car. Now the rear suspension on the car is going to be a multi-link suspension, which I had to explain in the suspension geometry part 3 video, which is a long overdue video that I actually never got to making, but I will get to making that later once hopefully I get done with this project. But just to briefly explain the multi-link suspension for now, what a multi-link suspension really is you can think of it as a double wishbone suspension with virtual pivots on both the lower and the upper control arm. So virtual pivots is something I explained when I was making the front suspension for this car. I explained that sometimes the manufacturers, they split the lower control arm on their front suspensions into two so they can actually push the pivot point of the suspension much further out to a point where you can't usually physically achieve a pivot point over there. That's really what a virtual pivot is. So if you do the same thing on both the lower and the upper control arms, the suspension you'll end up with is a suspension with 5 links and 5 completely individual links. And the benefit of this is that you're completely free in terms of geometry then to move the pivot points and things to wherever you want them to move. It gives you a lot of freedom in terms of design. And it also means that these links no longer have to be arranged in the same plane like they are in this picture. They can be moved around anywhere as far as the forces and the geometry works out properly. And that's really what you'll see in the car suspensions these days. Like for example, this suspension from the back of the E55, a multi-link suspension, you can see these 5 links are scattered all over the place, so it looks really confusing. But when you start to analyze it, all it is these 2 upper links that are doing the job of the upper control arm, these 2 lower links that are pretty difficult to see in this picture, but they're doing the job of the lower control arm. And then there's this last link at the back, which is called the toe link, which is doing the job of the tie rod end, basically not letting the tire change any toe angle. And that's really where the 5 links come along for the multi-link suspension. And when you put that all together, you get something really complex like this, and this is how the whole thing moves. Now this looks pretty confusing when you look at the whole thing moving at first, but let's get into how I actually got to designing all this. So I started off by bolting wheel spacers. The reason I was using spacers is because I didn't want to modify my axles, and since this car has a much wider track width than the E55, I needed spacers to move the tires further out. But I did make appropriate changes to the suspension, like I did move some of the links around to counter the forces that these spacers will add on the links of the suspension. I'll talk a bit more about that later in the video. But anyways, once the spacers were bolted on, next I got to bolting on all my ball joints. Now I was using the same bolting points that the E55 suspension uses, but the only difference was that they were using rubber mounted bushings at these mounting points, and I was using rod ends at these mounting points, ball joints basically, because I didn't want any compliance in my suspension. The only place I left one of the rubber mounted bushings in place is for one of the lower links of the suspension, so for this one I had to cut some sheet metal and make a bracket for it. And this control arm is also going to be in a bit of bending because the center of the hole doesn't really line up with the tube, but the tube was actually chosen in the appropriate thickness for this bending force, so even that's not going to be a problem really. Once all the ball joints were in their proper places, next I actually picked up the spindle and placed it inside one of the wheels and bolted it in place. After this, I took some time to actually measure out the locations of these ball joints in reference to the wheel, because I actually needed to know the position of these ball joints exactly in order to calculate or get my suspension geometry right. So next I went into the design and I designed the same thing. I designed the location of these 5 ball joints in reference to the position of the wheel. Once I had these positions figured, next I had to choose the location of these 4 ball joints, basically the attachment points on the chassis where these links that are the equivalent of the upper control arm and the lower control arm will attach to my chassis. So the position of these red attachment points that you see, these will actually determine my roll center and my pitch center and my anti-squat geometry of my suspension. So it was really important to get these positions of these red circles right, and the way I did that was just by moving the wheel around, analyzing how the contact patch actually moves, and yeah, just by changing them depending on what the wheel was doing. So obviously it took a few attempts to get this right, but once the locations of these 4 ball joints were figured, next I could actually get to figuring out the location of my toe link. So this location had to be chosen appropriately in order to make sure that the suspension would have no change in toe angle when the suspension was moving up and down. And once all that was put together, this is the way the suspension moves. So you can see that it's not just a simple up and down movement, it's actually a pretty complex movement. The tire is not only changing camber, it's also rotating slightly forwards, which is for the anti-squat geometry, and it's also, the contact patch is also changing its location laterally and longitudinally as the wheel moves up, and all these things are what gives the car its roll center and its squat geometry and the camber change and all those things that you need to get the suspension geometry working properly. So it's actually pretty complex to get this suspension right. That's why it's no surprise that multi-link suspensions never really came around until computers came around, because a geometry like this would have been close to impossible to get right without the use of computers. Once most of the design was figured, I started off by placing the wheels in their appropriate place, like they had to go on the car. Okay, so now I've positioned my 2 tires exactly like they're supposed to go up on the car according to the design, and I was using these tubes just to make sure that the control arms in the design do exactly line up with the chassis like what they do in the design, basically just making sure that everything is right. And next what I have to do is that I have to start fabricating the control arms and also the attachment points for the control arms. For making the attachment points, I did a bit of a lazy job to save myself some time. I started off with the flat bar and I drilled holes in it. And then later I cut the flat bar using my chop saw, just cutting it into these square shapes. And then I took 2 of these plates and just bolted them together with a ball joint, and that was literally the attachment point. After that I did plasma cut one end to make it fit onto the tube better, so that it could be welded onto the tube, but that was pretty much it. After that I just welded these attachment points in place. Once the lower attachment point was in place, I also had to add these 2 tubes on which the upper 2 attachment points would go. I didn't weld these tubes earlier because I didn't have the suspension geometry quite figured, because this tube, the location of this tube depended on where the upper 2 links of the suspension had to go. And once that was done, I also welded the upper 2 attachment points in place. Here's a look at the attachment points after 3 of the attachment points are done. So one of the attachment points for the lower link is done, and for the upper 2 they're done. So now I've left these links really rough, like usually I would be rounding these edges off and everything, but I just want to get things working for now. I'm really working in a rush, like just trying to finish everything. And after that, maybe later I will end up trimming all this and also removing this extra part of the bolt, because all that is literally just dead weight. So, but anyways, for now the thing I want to do is that I want to start making the links that have to like connect these ball joints to each other. For making these, it's going to be fairly easy. All I have to do is measure the distance between these two ball joints and then actually like cut a tube to that length, and then I'm going to be welding the threaded part into the tube. The same way, if you remember from when I was making the front suspension, the way I made the control arms for that suspension, it's going to be the same process, but hopefully even easier, because this time there's no control arm to make. There's just individual links going from each ball joint to the other. So for making the links, I started off by cutting the steel tube to length. After that, I inserted these threaded parts on both sides of the link. One side was left hand threaded and the other side was right hand threaded. This was so that I could turn the link and adjust the length of the link to make the adjustment easier later on, basically. Once all the links were made, it was just as simple as bolting one ball joint to either side of the link and just bolting it in place then. Once the other 3 links were made, I also got to this last attachment point that I left out before. And once that attachment point was made, I also finished up on that last link and just bolted that in place as well. Here's a look at the suspension after 4 of the links are in place. So these 4 links are basically the equivalent of the upper control arm and the lower control arm. So right now the wheel is fixed in its proper place, but the wheel is still free to change toe angle. So right now if I push it, the wheel can actually change toe angle, and that's because that last link, the toe link, is not in place. That link has to go from here to somewhere over here, and once that link is in place, the tire will also not change toe angle, then it will be fully fixed in its place. But the thing I wanted to show you guys right now is that there's a certain axis that when I turn the wheel, there's a certain axis where the wheel will tend to rotate around. On the front suspension it's called the steering axis, but on the rear suspension there is no steering, so there is really no steering axis, but that axis is still of somewhat of an importance, because the place where that axis meets the road surface determines what would essentially be the scrub radius in the front suspension, the distance between the center of the contact patch to the point where the steering axis meets the road surface. That point is really important because that point determines the forces on this last link that is going to go over here, the toe link, because the further you move the steering axis from the center of the contact patch, the greater the forces would be on that toe link when the car is accelerating or decelerating. So now, I talked in the beginning of the video that I added a massive 55mm spacer that moved the wheel much further out. So that means that if I would have gone with the same geometry that the E55 had, I would have ended up with massive forces on that last link, the toe link, and therefore also more forces on the 4 other links of my suspension. So what I did to compensate for that is that I did make some changes to the geometry of the suspension, and just to explain that better, this is the geometry of the E55 suspension. So these are their upper 2 links, and if you look at the way these upper 2 links are lined, if you draw an imaginary line through this link and if you draw an imaginary line through that link, the virtual pivot would be somewhere over here. But if you look at my suspension, what I did was that I crossed these 2 links over, and my virtual pivot is literally like somewhere over here, which actually pushes the steering axis, like angles the steering axis much further that way, and points the steering axis towards the center of the wheel rather than towards what it would have been if I followed the same geometry from the E55. It would have been way farther that way. And let me just mount the camera on the tripod stand and actually move the wheel around, because it's actually pretty cool to actually see that working. If you notice how the lower part of the tire is pivoting, the contact patch really, you can see that it's pivoting kind of around the center. You can see that better from this mark it leaves on the tire, that the mark is kind of towards the center of the tire. So the scrub radius in this essentially is like 50mm away from the center of the tire, which is actually pretty close to the same scrub radius that I left on my front suspension. And I know a couple of people were arguing such a big scrub radius would make the steering wheel incredibly heavy, but now that everything is done, you can see that the steering wheel is incredibly easy to turn on this car. And the reason is that you have to realize that when you put so much negative camber on the tire, the center of the contact patch, the actual center of the contact patch, actually moves inwards towards the inside of the tire. So to compensate for that, you have to bring the steering axis inwards too. Now that all other links of the suspension are done, the last thing I have to make is the toe link of the suspension, so the link that has to connect from that ball joint to this ball joint that is going to go somewhere over here. And this link is really important because this will determine how the suspension changes toe angle as it moves up and down. And because this is a rear suspension, it is really critical for this not to have any bumps here. And if it has bumps here, I want it to be a slight bit of toe in, if anything, not toe out, because toe out at the rear causes an extreme amount of instability at high speed. So what I'm going to be doing for this last link is that I'm actually going to be going slightly longer and slightly higher than the position that I should be going for this. I'm just going to be tack welding everything in place, and then I'm going to be measuring for bump steer. And if there is too much bump steer, then I'm going to be like making those appropriate changes to actually get the suspension back to minimum bump steer. For making this last attachment point, I made a really simple attachment point. I just used a tube and bolted this ball joint to it. This was because I knew for sure that I wouldn't get the attachment point right the first time, because it's a really complex suspension and getting zero bumps here in a multi-link suspension is extremely difficult. So I knew for sure I would have to make a few changes before I get it right. That's why I used this tube with this ball joint, so I could tack weld it in place, and then if it is not right, then I can simply break the tacks off and re-weld it in a different place until I get the position right. So now I've made this last link for the suspension the toe link, but I've made it slightly longer and slightly higher like I mentioned, and I've only done it for one side right now because I want to get one side right first, and then I'm going to be making the one for the other side according to that as well. And for checking for bumps here, I'm using the same test that I did when I was making the front suspension. I believe it was part 7 or part 8 of the video series, but I'll just add a video card somewhere on the screen wherever it goes, so you guys can find that. But yeah, it's basically the same test. So there was a laser over here. The laser is pointing at that aluminum thing over there, which has this grid that I made, which is going to tell me how much the tire is changing toe angle. So basically this is 0 degrees right now. What I'm going to be doing is that I'm going to be raising the car to its maximum ride height, and then I'm going to be lowering it slowly to all the way to its minimum ride height. So hopefully if the suspension has bumps here, which it should have right now, I will see this laser change, and if my everything is right, then I'm hoping this laser should go this way. And right now it should be going this way more than 0.5 because I've left that toe length longer than it needs to be. But the thing is that I need to find out how much it moves this way by. So depending on that, I'm going to be adjusting the length of the toe link and hopefully getting it to a point where the bump steer is then in between 0 and 0.5. Then that would be good enough for me. A couple of people asked last time that how I actually measured this out, like how I came up with this grid. So it's basically simple trigonometry. I've actually done the maths over here this time so you guys can see it. So 440 centimeters is the distance between the rear tire, basically where the laser is positioned, and this aluminum thing. And 1 degree, like I was looking for the distance of 1 degree, so it just comes out to this simple triangle, and then you just do tan 1 equals x over 440. That gives me 7.68. So this distance between the 0 degree mark and the 1 degree mark is 7.86 centimeters. That's how I came up with this. So after that, I kept an eye on the laser and slowly lowered the car from its topmost position to its lowest position. And this time you can tell that there's quite a lot of bumps here actually. It was toe in, but it was quite a lot. It was about 1.5 degrees, I would say. That's about where it seems like. So obviously the car would have felt like crap to drive if I left it like that. So next what I did was I broke the tacks off, and now at least I had some type of number, like how much I was looking to move this attachment point by. So what I did was that I lowered the attachment point slightly this time, and I also moved it inwards. Now the changes I'm talking about over here are just like a few millimeters. Like visually you can't even tell what these changes are. They're really small changes. It really takes a small amount of change to make a big amount of difference in bump steer. So here's the second time I did the same test, and this time you can immediately see that there's a big difference in the results. The bump steer is like 0.8 this time. So this time doing the test twice, I obviously knew where I was going with this, so I could trace the points and get to the final point where the bump steer would be minimal. And when I did the test the third time, it was pretty much no bump steer at all, so that was the perfect point that I needed to get to. So once I had one side figured, all I had to do was copy these exact same values on the other side and hope that that side also gets 0 bump steer on these values. And that's exactly what happened actually, because when I did the test for that side, from the start I got 0 bump steer on that side, so that was pretty good. Here's a final look at the multi-link suspension after everything is complete. Well, not the welding is still left, but everything other than the welding you can say is complete. I still haven't finished the welding because I'm pretty low on welding gas right now. That's why I don't want to complete the welding right now and get stuck with it midway. I'm just gonna wait for that till the next week, till the next video. You guys will get to see all the rest of that then. But functionally, all the suspension is complete. Like, this is the way it's gonna function. And it's pretty cool to see, like, now when I move the suspension up and down, I can actually see all those things, like just like the suspension was in the software. Like, you can see the spindle rotating forwards because of that anti-squat geometry. You can see the camber changing, and yeah, basically all those things. It's amazing to see that on the real suspension, and to actually see it working flawlessly without any bumps there. Like, look at this thing, it looks completely insane, like 5 links going all over the place. It looks like something impossible that would not even work, but it actually does work. I think that's the coolest thing about it. But talking about the numbers of the suspension, actually that's the other thing I needed to talk about. So the anti-squat geometry in the suspension would reduce squat by 30%. That's a bit of an estimate actually, because the actual number depends on the center of gravity of the car. So the center of gravity is a bit of an estimate right now based on the masses I calculated for all the parts, but it should be somewhere around 30%, what I mean by that, which is a pretty good number for this car, I think, because what that means is that if I hadn't gone with any anti-squat geometry at all, the car would have squatted 30% more under acceleration, and I would have needed 30% stiffer springs to compensate for that squat. But because that anti-squat geometry does the work for me, I don't need springs that are that stiff. Also talking about the roll center that I went with, the roll center on this suspension, well, it's a little difficult to calculate because on a multi-link suspension it's a mess. It's really difficult to calculate all these things, but it should be somewhere around 11 centimeters. At the front it was somewhere around 9 centimeters, so it's just slightly higher than the front, but it's still a pretty close number. So I think this suspension should be a pretty good match for this car with the front suspension. Now the last thing that's left on the suspension, which you guys are going to see in the next part, is a push rod part. There's going to be a push rod that's going to come out from here. This is one ball joint that I've left in the suspension, and that push rod is going to then continue till over here, and you're going to see a similar setup that you see on the front over there with the cantilever and the coil spring. You're going to see a similar thing at the back over here as well. And I also have some finishing up to do on the differential, which I know I said I would do in this video, but this was a lot of work. Come on, like, this is more than enough work for one video, I think. Also, just going over some of your questions from the previous video about the differential and the drive shaft, a couple of people commented that isn't it risky running the drive shaft through the center, like where the driver and the passenger sit. Well, this is pretty much the setup you see in every production car. The drive shaft is passing from in between the driver and the passenger. There's just a transmission tunnel that goes over the drive shaft, so even if the drive shaft breaks, it's not really a problem because the drive shaft can never really escape the transmission tunnel. Now obviously you guys are not going to get to see all that in one video. I can't do that much work in one video. The transmission tunnel is going to have to wait till later when I actually start work on all the aluminum panels that are going to go in this region over here. So there's going to be the aluminum floor, the aluminum crash structure on the side, so that if someone crashes into the side, nothing comes into the car, and also the firewall at the front. So once I do all that, that's when I'm going to be making the whole transmission tunnel and everything. But yeah, that's going to be everything for this video. Definitely try to stay tuned for the next video as well, because that's also going to be a really cool video. That's when you're going to see the whole push rod setup for the back, and possibly even the rear crumple zone. And after that, the car is actually going to be standing on all 4 wheels on its own. So I definitely can't even wait to get till that part. Hopefully that should be coming in about a week, depending on how quickly I work. I'm trying to work as fast as possible at this, by the way, because I'm trying to get done with this car. Hopefully get it running in a month or something. That's what really I'm planning to do, so I can actually get this car on the track by September. It's a pretty tight deadline, but I think working the way I'm working right now, I can get it done. So yeah, definitely try to stay tuned for the next part. Thanks a lot for watching, and see you guys in the next one.